For centuries, humanity has stared into the night sky and whispered the same questions. How far does the universe go? How tiny are we really? And is there a limit to what we can ever discover? But now, a new answer has emerged, and it didn't come from myth, philosophy, or imagination. It came from a machine floating nearly 1 million miles from Earth. The James Webb Space Telescope has just sent back data so astonishing, so reality-bending, that scientists around the world are being forced to rewrite the very foundations of cosmology. Galaxies appearing where there should be emptiness. Black holes forming when the universe was still an infant. Clouds of dust giving birth to stars we can now watch grow in real time. And that's only the beginning. Because with a single observation, Webb didn't just expand the known universe, it revealed a secret too vast, too complex, and too ancient for even our boldest theories to contain. A secret that may change humanity's place in the cosmos forever. The James Webb Telescope was never designed to simply replace Hubble. It was engineered to be something far greater, a time machine capable of reaching the first light after the Big Bang. With a mirror 6 times larger than Hubble's and instruments that see in infrared light, Webb can pierce through cosmic dust, unveiling the hidden structures of the early universe. It was built to look not millions, but billions of years into the past. And it succeeded. When the first images came in, scientists went silent. The darkness of the sky wasn't dark at all. Where previous telescopes saw faint smudges, Webb revealed oceans of galaxies, each holding billions of stars, planets, and perhaps life. But what truly shattered the scientific community wasn't the number of galaxies. It was their age. Webb found mature, structured galaxies, spirals, disks, even dust-rich systems, in a universe only a few 100 million years old. According to every model we had, these galaxies shouldn't exist. This leaves us with 2 possibilities. Either the universe evolved far faster than we ever believed, or there's something fundamental we've misunderstood for decades. As Webb gazed even deeper, a cosmic blueprint began to emerge. An invisible structure, a cosmic web of dark matter and gas, stretching across billions of light years. Regions of space once believed empty turned out to be crowded with galaxies forming patterns that defied randomness. They were connected by massive filaments, intergalactic highways carrying matter and energy across the universe. And Webb wasn't just photographing them. It was measuring them. With its powerful spectrometers, Webb analyzed the chemistry of distant galaxies, the temperature of gas between them, and even the signatures of life-building molecules drifting in the coldest corners of space. The universe that emerged from this data was not quiet or simple. It was alive, colliding, merging, consuming, creating. Galaxies weren't static islands. They were ecosystems feeding on gas, expelling matter, reshaping themselves again and again. The universe wasn't built in silence. It was forged in fire. What makes Webb so unique is not just its reach, it's its patience. For the first time, we're watching the universe change. Stars forming, dying, exploding into supernovas. Black holes awakening and consuming entire systems. In distant galaxies, we're tracking light from stars that lived and died billions of years before Earth existed, and yet we're watching their final moments now. But then came a discovery that stunned even the most skeptical astronomers. Webb began reading the atmospheres of exoplanets, alien worlds orbiting distant suns. Using transit spectroscopy, it captured light filtering through their skies. In that light, Webb found water vapor, methane, carbon dioxide, and even complex organic molecules, the same molecules that helped spark life on Earth. It wasn't proof of aliens. But it was something equally shocking. Proof that the ingredients for life may be common, everywhere, scattered through the universe like seeds waiting for a garden. And Webb didn't stop at planets. It looked into the so-called emptiness between galaxies, the intergalactic medium, and discovered it wasn't empty at all. Vast amounts of gas, ancient elements, and even free-floating planets, worlds with no star, wandering alone through eternal night. These rogue planets weren't rare. They were numerous. The universe wasn't a lonely desert. It was crowded. As Webb uncovered more structured galaxies in the early universe and familiar chemical signatures billions of light-years away, a strange idea began spreading, quietly at first. Are we inside a simulation? It sounds like fiction, but Webb's data pushed even grounded scientists into uncomfortable questions. The universe appeared too precise, too mathematical, too consistent across impossible distances. Quantum physicists have long suspected that our reality may emerge from something deeper, something like code. And now, Webb's findings, the symmetry, the uniformity, the repeating patterns, reignited the debate with new intensity. If the universe is a simulation, Webb might be the first telescope powerful enough to notice the seams. And then came the anomaly. During one of Webb's deepest scans, the telescope captured a repeated pattern embedded within the light of a distant galaxy cluster. At first, it was dismissed as data corruption, then as interference, then as coincidence. But after weeks of verification and repeated scans, one thing became undeniable: the signal was real. And it was not random. It didn't match gamma-ray bursts, pulsars, quasars, or any known cosmic phenomenon. It pulsed at intervals that appeared deliberate, almost like information. Is it an advanced civilization? A relic from the early universe? A cosmic echo from the Big Bang? No one knows. But something out there is speaking, and Webb is the first to hear it. Webb also challenged our understanding of dark matter and dark energy, the invisible forces that make up 95% of the universe. By mapping distortions in light, Webb traced the gravitational imprint of dark matter with unprecedented detail. But the results were disturbing. Dark matter didn't behave consistently. In some regions it clumped. In others it diffused like smoke. And dark energy, the force accelerating cosmic expansion, may not be constant at all. If that's true, then our entire model of physics collapses. Gravity, time, even reality as we know it might be emergent, not fundamental. Webb isn't just expanding the universe. It's revealing how little we understood it. But one mission stands above them all: the search for biosignatures, the chemical traces of life. Recently, Webb detected the spectral fingerprint of dimethyl sulfide, a molecule produced on Earth only by life, on a planet 120 light-years away. It's not proof of aliens. But it is the closest humanity has ever come. If confirmed, it would be the single greatest discovery in human history. It would mean life has taken root somewhere else, quietly, naturally, inevitably. And Webb would be the telescope that heard its whisper. The James Webb Space Telescope was built to answer our deepest questions. Instead, it shattered them. From galaxies that shouldn't exist, to signals that refuse explanation, to molecules that hint at life, to dark matter behaving like something alive, Webb hasn't just shown us the universe. It has forced us to confront the truth that we've only begun to understand the canvas we're painted on. Beyond every discovery lies a deeper mystery. Beyond every answer, 1,000 new questions. And as Webb continues to stare into the darkness, the universe stares back.